What up, what up? Today we are talking about linear translations. The heck is that? Linear means straight line. And as you may remember from earlier this year, translate means to move it. Or as our friends from Madagascar, that place, like to say, I like to move it, move it. That joke is now destroyed because of my stutter. That's all good. All I have to do is just read what's on the slide, and I can't possibly go wrong from here on out. Except that my face is in everything's way. Always in the way is my face. Can I squeeze my face? Nope. Linear transformations, basically, or translations. Basically, what we're looking at is if I give you a line of some kind, right, and I move it up, down, left, right, make it steeper, make it upside down, make it shallower. What would that do to the equation that I'm given? Well, let's look at the three possibilities that we have. If I were to take a line and have that line move up or down, that would be called a vertical translation. Now, what a vertical translation looks like is I'm just going to add a regular number, constant, at the very end of my equation. So if I were to graph the line y equals x, it would be great if I had a pen. If I were to graph the line y equals x, right? And I were to just simply do this to it. Like, it looks like I moved it up. In fact, it was right here. That's y equals x. That's a parent function. That is the simplest possible linear equation known to man. If I were to add 3 to that, okay, I'm literally taking my line and going 1, 2, 3. That's it. If I were to make this minus 2, I'm literally taking my line now and I'm going minus, here's my line, that's my original, I'm going to go down 1, 2. That's it. That is a vertical translation. All I do is I basically take my y-intercept and I add to move it up or I subtract to move it down. Done. 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 A horizontal translation is if I were to take a constant and I'm going to try to move it. No, it's not that one. I know this is just going to make my face bigger. Is it this? A horizontal translation is if I want to take that y equals x again. So I'm going to try to draw a nice perfect diagonal. I could have done better. Oh my gosh. Can I undo? Yeah, we'll just reset the page. If I want to take that line and if I want to move it left 1, 2, or move it right 1, 2, 3, this is what you do, and it's backwards land. When you move left to right, it's backwards land. You have stuff moving inside or living inside of the parentheses, and if I subtract 3 inside the parentheses, I know you're thinking, move left 3. Actually, if you subtract 3, you move right 3. So a negative number inside that parentheses means you move right. And a positive number, so if I were to make that plus 3, a positive number would be me taking the original equation and we're moving it 1 left, 2 left, 3 left. Right there. Okay. Now, what if I wanted to make it steeper or more shallow? Well, the number in front of x is a slope. Okay, and what we're going to do is we're going to manipulate the slope to have it do whatever I want. Now, this is called a stretch or a compression. If I were to take a number and multiply it to my variable x. In other words, my slope. Okay, if I were to put a 2 in front of this, that would be a positive number that's being multiplied to my variable, and that's going to make my line steeper. That makes sense. A slope of 2 is steeper than the slope of invisible 1. All right? Any number in between 0 and 1, for example, and let me write it up here because I didn't really give myself a whole lot of space. If I were to take y equals x and throw a half in front of it, okay, now instead of going up 1 over 1 and having that, I'm going up 1 over 2 and having a shallow slope. So any number between 0 and 1 makes it more shallow. Now you might be thinking, why don't you just say any number smaller than 1? Well, if I have a negative slope, it flips. So the same rules apply. It's just now, if for any reason, if I were to say, well, let's make the number in front of x 3, all right, there it is, but make it negative, all right, now there it is. So pretty steep, but negative slope. All right, so if I were to put that all together into a nice little equation, like that one, I can basically look at an equation and know exactly what to do with that equation. Right? If I were to give you something like y equals 3 x minus 4 plus 2, right? And I'm going to draw a very rough draft, okay? I know that my slope is 3, which is pretty steep. I know that being negative 4, it's going to move left 4, and I know it being, it's going to move right 4. I fell for it. It's going to move right 4, and being that it's positive 2, it's going to be up 2, and my slope of 3, that should have started right around here. So if this is x, right? If that's 3x, by throwing that minus 4 in there, I move it right 1, 2, 3, 4, and then that plus 2 means I move it up 2, and then I have a line that looks something like that. Now, this equation is kind of special because it looks like an old friend. If I were to take an old friend that looks like this, and if you're like, oh, I recognize that, that's point slope form. And if I were to add y sub 1 to both sides, like so, and then turn that m into k, and then turn that x into h, and then turn that y into v, it's the same exact thing. So this is point slope form manipulated. And remember, point slope form gives me a line given the point and the slope. And when I take like something that's like an equation that's centered around an origin, right, and I make it 3 times as steep, and then I move it this way and that way, I'm just having a slope and a point. Those are my knuckles. So let's see how we're going to use this today in my Back to Basics video. I'm given a function. I'm given 3x minus 4. I know what that looks like in my head. I know in my head that I have something that starts at negative 4 way down here and is very steep. I know it's going to look like that. But what if I turn it into negative 3x minus 2? Well, if I make it negative 3x minus 2, 2 things happen. That positive 3x is now negative 3x. So what happens here? It flips. Okay, so my line went from that to that. Now that minus 2 used to be minus 4. So by turning negative 4 into negative 2, I moved up 2 units. So my line changed in 2 ways. My 3x became a negative 3x. All right, great. It looked like that, now it looks like that. My negative 4 became negative 2, which means it just moved up higher 2 units. That's it. That's it. That's it. That's it. That's it. Oh, much worse. Ugh. All right, well, let's see what happens. There's several things. There's 3 things that I care about. The number in front of x, the number next to x, and the number all the way at the end that's floating around all by itself. And it looks like we're dealing with all 3 of those things. So let's look at the number in front of x first. Let's look at the difference between the two. 4 became 8. The difference between 4 and 8 in multiplication terms is times 2. So what happened? It's 2 times steeper. Because 8 is 2 times 4. My x has no parentheses, so invisible parentheses is now x minus 2. So I'm now subtracting 2 within a parentheses next to x. When I subtract 2, that means I move 2 to the right. Remember, it's opposite land when it's inside the parentheses. And if you're wondering why, well, because when I showed you point slope form, it was x minus x sub 1, so it's opposite when you're living inside the parentheses. That 1 is now a negative 7. And to go from 1 to negative 7, you subtract 8, which means I move 8 down because we subtracted 8. Alright, so what used to look like this, 4x plus 1, is now steeper, moved to the right, and moved way down here. Pretty exciting. Pretty exciting. Take g of x, g, equals 3x plus 1, make it half as steep, move up 3, move right 4. I can do this. It's a little out of order, but I can do it. G of x, to make it half as steep, that means I need to multiply a half to the number living in front of x. So half of 3 is 3 halves. So 3 halves. To move it up, let's save that for last. To move it right 4 means I need to take my x inside of the parentheses, and when you're moving it right 4, it's opposite land, so it's minus 4. Close that parentheses, and if I'm moving it up 3, I'm taking 3 and adding it to that 1, so 3 plus 1 is 4, and that's my equation. Very bizarre lesson. It's basically teaching you how to graph equations or understand the graph of an equation without the use of a calculator. Or without having to do a whole lot. If you just remember, well, if I manipulate the number in front of x, or if I manipulate the number contained within a parentheses next to x, or if I manipulate the number all the way over there, I can make it, like, thinner or more shallow, or move it left, or move it right, or move it up, or move it down. Stuff like that. Okay? Translations. More than meets the pie. Math. Bye! Oh, I should have said more than meets the bye. Translations, more than meets the bye!